Hello everyone. So in the previous video we have come across basics part 1 of logarithmic functions. Today we'll be moving on directly towards the limits. So you have studied this topic previously in differentiation, just before differentiation, that is differentiability and continuity. In that you have come across something called as limits and continuity, correct? No? So that only a little more in depth we'll study, and we'll try to apply this concept into other concepts. As I told you in the previous video, it's all about understanding one concept and applying that into all the other concepts of mathematics. So going on to this one, so limits is nothing but a function which will exist. That means a limit of a function will exist only if the left hand part of it, left hand limit, is equal to the right hand limit. Okay, so then only I can apply something called as a limit. So limit is an operation. Okay, I will, something like differentiation is an operation, logarithm is a function, it's not an operation. So limit is an operation, differentiation is an operation, integration is an operation. So not hospital operation, not a body operation. Okay, it's mathematical operation. So very clear. So I hope you all don't get confused with that. Okay, so now here the limit is an operation which can be applied to a function only if the left hand limit is equal to the right hand limit. Okay, so to give you all a better idea of that one, you have already studied about it anyway. Suppose if I go applying a limit of a function, this is f of x if I tell, and this is a negative value. You already know these are the negative numbers like -1, -2, something like that. This is a negative part of it, and this portion is a negative portion of that one, that is f of x. You will get it as f of x of minus something over here. Then to the right hand side also it goes on in the same way, that is towards the positive side also f of x, this will be minus and this will be plus. Now if it comes and meets at one point, you all know if the left hand limit and right hand limit is same, then it is a continuous function, correct or not? So if it is a continuous function, that means the limit will exist. So first comes limit existing or not. If the left hand limit becomes equal to right hand limit at any point of that function, okay, at any point of that function, left hand limit holds good for a right hand limit. That means both are equal. This condition is very important for you to understand. Left hand limit, you can see this is a plus side of it, and this is the left part of it, that is the minus part. So right hand limit is equal to left hand limit. Then only I can apply a limit operation to a function. So then only I can apply it. Otherwise, the limit operation will not hold good for a function. So that's the basic of understanding limits. Then you have something called as properties of limits, which will be helpful in solving the problem. I will display the properties in the video as well. So please go through it clearly. Then look into what I'm explaining also. Okay, look into that formula, whatever I've written there, and then after that you look into what I'm explaining. It is very simple and you have studied this already. So keep your mind clearly and understand what I'm trying to tell. So here property number 1, addition of two functions. If I add the two functions and apply limit to that, then it is same as applying limit to individual functions and then adding them. It's very simple. You can see in the image what I have written, that is written over there. Limit of f of x plus g of x is equal to limit of f of x then plus limit of g of x. Yes, so in the image you can see it clearly. So limit of addition or subtraction, plus or minus, it holds the same. Limit of plus first function or minus of the second function. So limit can be applied to addition as well. The first one is very easy, I need not explain that. The second one is product. Again, same. If the product of two functions is given in limits, and what you need to do is you need to apply limit to both the functions. So it is same as applying individually both the functions. Individually I can apply the limit to individual function first, limit of f of x, then multiply it to limit of g of x. If I multiply those two, I will get the same answer as that of putting the limit to the product as well. Okay, so that is also similarly. So I can just write it once. Limit of x tending to some value a, whatever it might be. So f of x is something like this. Imagine product g of x is equal to limit of f of x, first function, product of limit of g of x, the second function. Okay, if you all are getting confused with what I am writing here, g of x, f of x, it is nothing but function of x. This is first function of x, this is the second function of x. You can name it in any other way. It's just a function, or it can be a quadratic equation, cubic equation, whatever it is. I'm just applying the limit to that particular equation. Clear? So understanding this is important. So product can be separated as well. Same goes to this one is first, then the one, then the same goes to quotient, and you all have studied this already. Let me just explain this quickly. So in case you have doubt, please put a message. I will explain this in detail for you maybe. Okay, let's save time as much as possible. So here it is also the same way. Limit can be separated and applied for numerator and denominator. Numerator function and denominator function. Okay, so you might be asking, why are we learning this all of the thing again? You will come to know where this can be applied when these silly things are needed for your competitive exams, anything it might be. So these things you need to know, and you need to always remember almost all the questions are not going to be difficult. So there are some questions which might be difficult, but there are most of the questions which needs just the basics. You don't need anything complicated formulas and all that. You just need the basics. You apply these basics, you get the answer. Okay. So now the third one is again a little different in this. The limit of x tending to a, c into f of x. Okay. Imagine a constant into function. Applying the limit to a product of a constant and a function. So it is simply limit cannot be applied for a constant. A limit of a constant is a constant itself. Okay, so remember that. So that's why constant is kept outside. Then I can apply limit to the function. Okay, let's applying limit to the function extending to it. This is how it will look like. Just keep the constant outside and then apply the limits. So then after that it comes plus or constant plus or minus limit of f of x. That is, if there is a constant and a plus or minus function is there, just put the constant outside, add that and apply the limit. Okay, it's something similar to it. Instead of product, it's going to be plus or minus. It is addition or subtraction. Okay, I hope it is clear in the image itself, the picture which I am displaying. Look into it and understand what I am trying to tell. Okay, if you don't understand, please rewind once again and try to understand my words. I am trying my best to make myself clear. So if you don't understand it once, you can repeat and see it again. And in spite of repeatedly seeing this video or not understanding, please put a message. I will reply. I will respond quickly and prepare another video maybe, or maybe I can clear anyway, like however is comfortable for you. Okay, let's do it my best. Okay, then after that comes another one, the property limit of x tending to a, f of x whole power n. Okay, f of x whole power n. It is simply nothing but limit of a powered function. Okay, or there is a power in present in that one. I can just apply the limit to the function first. Suppose you can imagine it was a square like this. I'll give an example. This is n and this can be whole square. It's something like this. If you have a question something like this, x square plus 2 the whole square. So this can be written some first like that. X tending to 2, x square plus 2 the whole square. So what will happen here is, as soon as I apply the limit of 2, it will change itself into 2 square plus 2 the whole square. Isn't it? Even if it was here, this thing, 2 plus 2 the whole square only it would be. And even if you apply the limit to this function and then square it also, it's going to be the same. It's going to look like 4 plus 2 the whole square. 6 square, that is 36 is your answer. Okay, so this particular example is going to clear out a lot of doubts you have in your mind. So please look into it and rewind it and see it once again. You'll understand much better. Okay, then moving on to the next one, that is the power function is over. One theorem which you have studied many times, I'm sure, and you have forgotten it more than times you have studied as well. Okay, so when I write it, you might recall. Just let's see if you can recall this. It is going to be something like this. Okay, this has appeared in the examination as well, so I'm sure at least when you look at this formula you have some memories. Okay, so here it's going to look like x to the power of n minus a to the power of n divided by x minus a. When you apply the limit same as that of the constant number present here, I can just write it as n into a to the power of n minus 1. Okay, just applying the limit, and this you have derived in your normal syllabus examinations as well, correct? No? So if in case you are not able to recall it, please turn the pages of your book and recall this one. This is very important thing needed for your competitive exams as well. So if you remember, and you don't forget the limit of this one, it is limit of a, which means the number present here should be same as this in order to apply this formula. Remember, the limit and the number present here, the constant present here, should be same in order to apply this formula. If this was something else, if it was like this, I cannot apply the formula. Clear? So there is a possibility of asking in the exams. How they will ask in the competitive exam is they will give it like this, and they will give the options like this. There will be an option, and one option will be there, none of the above. You understand what I'm trying to tell? If they'll give you the limit as b and then give this formula, and you have in mind that this will be your answer, n into n minus 1, this will be your answer, and you'll end up ticking that, but it will not be that answer, and some option will be present, it is going to be none of these, and that would be the answer. Clear? So that is how they can ask a simple formula as a twisting question, just to make sure your mind is present in the exam. That is all they want to try to find out, like how capable you are about controlling your brain. Even this 60 minutes of time you have, and you need to control your brain in that 60 minutes and thinking about everything. These are very silly things you need to think about. So you need to think about it, look into it carefully. Your observation methodology, they'll come to know. If at all you mark that, which means you are very careless, just looking at this one and quickly marking some random answers, you have not understood the concept of limit. That's what they can assume from your answer tickings. Okay, that's all they are trying to find out in competitive exams. Understand how you understand what they are trying to take from you. Okay, so keep that in mind and then attempt a competitive exam. It will be much easier for you. Okay, so that one was the first theorem type of formula which you studied. Then there are many. I'll put a picture, so let this move on.